Hi students, today we are going to learn about temperature coefficient of resistance for a conductor and a semiconductor. Okay, yes. For conductor, temperature increases means the resistivity also increases. In last class we discussed about it, isn't it? The resistivity formula is that is a rho T at a temperature. At T temperature, the resistivity is equal to rho 0 into 1 plus alpha into T minus T0. This is the resistivity at T degree Celsius or T temperature. Then rho 0 is the resistivity at 0 Kelvin. Okay, yes. When temperature increases means in a metal or conductor means metal, the metal has free electrons, isn't it? That free electron, n number of free electrons available in unit volume, that is meter cube, isn't it? N is the number density, that is number of electron per unit volume, that is small n. So in a metal or conductor, we have n free electrons in a 1 meter cube. Okay, so temperature increases means that free electrons kinetic energy, the free electrons kinetic energy, average kinetic energy, here kinetic energy bar, that is average kinetic energy also increases. Due to this kinetic energy, it collide with each other. The free electrons are collide with each other. Therefore, due to this collision, current decreases. Current will decreases. Therefore, current decreases means we consider that resistivity increases, because resistivity increases, so current is decreases. But temperature increases means the free electrons, the average kinetic energy is increases, so resistivity increases. Okay, yes. Therefore, we taken that alpha value is as positive. So alpha is positive, so only resistivity is increases, because alpha positive. So 1 plus alpha del T, that is the change in temperature. So 1 plus, here alpha positive means it is positive plus, therefore 1 plus means it is addition term, therefore resistivity increases. Okay, yes. But in that formula, we should convert in terms of resistance, that is resistance is directly proportional to length and inversely proportional to area. So we should introduce a constant, that is resistivity L by A. Here length of the conductor and area of the conductor is constant, therefore resistance is directly proportional to resistivity. Therefore we convert that resistivity formula into resistance formula, that is RT, that is resistance at T temperature is equal to R0 into 1 plus alpha into change in temperature, that is T minus T0. Okay, then we are going to derive a formula from that one for alpha, that is the temperature coefficient of resistance formula. We are going to derive from this equation. So we multiply that R0 into that one. So R0 plus R0 into alpha del T, that is T minus T0. So we rearrange that one. Therefore R0 is coming that side. Therefore RT minus R0 is equal to R0 alpha into T minus T0. In terms of alpha is equal to this is we should rearrange that equation in terms of for alpha. So for temperature coefficient, so alpha is equal to RT minus R0 by R0 into T minus T0. So this is increase in resistance. This is increase in temperature. Increase in resistance means del R or change in resistance. Both are same. Increase or change. Change means here increases. So del R by del T into R0. So we convert that term into change in resistance, that is RT minus R0 means increasing resistance, so del R. Then T minus T0 is change in temperature, that is del T. Therefore alpha is equal to del R by del T by R0. In last class we given that one definition for alpha in terms of resistivity, but now we are going to give a definition for alpha, that is temperature coefficient, in terms of resistance. So it is called as temperature coefficient of resistance. That formula alpha is equal to in terms of resistivity. So this is known as temperature coefficient of resistivity, but both are same. Okay, this is del R by del T. In last class, like that way we are going to give one definition, that is del R by del T means rise in temperature, rise in a resistance per degree rise in temperature. So del R, here del R by del T divided by R0. Therefore, alpha is temperature coefficient of resistance is defined as ratio of, that is resistance, increasing resistance per degree rise in temperature to resistance at 0 Kelvin or resistance at T0. Like that way we will give one definition. Okay. For in graph we should explain in terms of graph, because in 1 marks this graph wise question will ask. Okay. So in graph we plot a graph between temperature and resistivity. So in large scale temperature the resistivity increases, or resistivity increases in linear manner for conductor. So it is linear, straight line. But in small temperature, very low temperature, the resistivity is not a non-linear. Sorry, it is not a linear, that is non-linear. Okay. So at a low temperature, the resistivity is non-linearly varying in conductor or for conductor. So in that term, that is not a linear graph. This is one curve like, therefore that is non-linear. So there is a graph between resistivity and temperature. It is a linear for a large amount of temperature, but a very low temperature the resistivity is not a linear, that is non-linear one. Okay. Yes. Now we are going to discuss about that is a semiconductor. In 9th lesson we will learn about a semiconductor very deeply, but now we are little only going to learn about a semiconductor. Semiconductor means in a last orbit, that is valence orbit, it has 4 electrons. So all atoms want to be stable. So it in that last orbit the atom or the atom must be have 8 electrons. That is acted rule. Due to this acted rule, last orbit 8 electrons means that atom will be stable one. But in semiconductor, in last orbit it has 4 electrons. So it want to be stable means it donate the 4 electrons, otherwise it accept the any 4 electrons from other atoms. So it is the semi type, like Madil Mel Pune. So where it will be donate or accept. So it has 4. So it is in confusion state. So semiconductor, solely it is called as a semiconductor. If temperature rises means it will be acted as a conductor, or its resistivity decreases. So it acts as a conductor. So temperature is inversely proportional to resistivity, or resistivity is inversely proportional to temperature. So temperature increases means resistivity decreases. So alpha is negative, because in that formula, that is a resistivity formula, in here RT is decreases due to alpha, because here minus term means 1 minus, so some fraction or some amount of terms will be reduces, so RT is also reduces. Here alpha negative means 1 minus, so this term is reduced or decreases, therefore resistivity is decreases. So alpha is negative for semiconductor. So therefore the negative alpha means the material is known as thermistor. So thermistor means a semiconductor are called as a thermistor if a material has negative alpha, that is negative temperature coefficient, means it is called as thermistor. Okay. For semiconductor, the graph between rho and T is non-linear. So temperature increases means the resistivity is decreases. So temperature increases means resistivity is decreases, like that way. So it become as a conductor. So it conduct very well. Okay. At high temperature, the the semiconductors are a better conductor. Okay. Yes. How it is conduct? So resistivity how decreases. Okay. Resistivity decreases, so it conduct. Then how it is begins, or how it is become a conductor means here rho is equal to m by n e square tau. We discussed in that is microscopic model of current. Rho is equal to m by n e square tau. Here n is the number density, tau is the that is average free, that is mean free time, isn't it? So tau is the mean free time, that is time taken between two collision or one collision, average time between two successive collisions, or time taken between one collision. If temperature increases means number of electrons is increases in a semiconductor, but in metal temperature increases means n doesn't varies. So n is constant for metal or conductors, but temperature increases means n, that is free electrons, is produced in a semiconductor. Therefore, number of electrons is increases, so resistivity is decreases. At the same time, the tau is also decreases, because a lot of number of electrons means the two electrons, the time taken for collision for between two electrons is decreases. So tau decreases, therefore that is rho is increases, but it is that is yes, both are inversely proportional, but tau is decreases, so resistivity increases, but n is that is dominated in semiconductor, because lot of free electrons is produced in semiconductor at a high temperature. So temperature increases means n is enormously increases, therefore it is enormously increases, therefore it is decreases. But here tau also decreases, because lot of electron is available means the time taken between collision is decreases, because it is near by near. So it is time taken for collision is decreases. But here n is very large, therefore it is not depend that rho value. Okay, but here tau is inversely proportional to resistivity, therefore here n electron is available, number of electron is independent of temperature for conductor. So tau increases here, tau decreases, because it get high energy, isn't it? So due to this collision, it high energy, so it is very fastly moving and collide with each other, therefore tau is decreases. Tau decreases, that is time taken, mean free time or time taken for collision is decreases means resistivity increases, therefore here resistivity increases for conductor. But here also that same one, tau is decreases, because time is decreases, but resistivity is increases, but it is eliminated by that n, because large number of electrons is produced, therefore n is increases, therefore resistivity is decreases. So number of free electron is dominate that tau, okay, for in semiconductor. Like that way we are here in between that conductor and semiconductor we have alloys. Alloys have low alpha value, that is a low temperature coefficient of resistivity, because it has some special quality. So only we use the alloy wire for many practical things. Okay, so alloys has temperature, that is temperature coefficient value is low for alloys, but here for metal or conductor temperature coefficient is positive. For semiconductor temperature coefficient of resistance is negative. For alloy temperature coefficient of resistance is low. Okay, then another one small term we are going to learn. Here after that 0 Kelvin reduces the temperature, means we are going to reduce that temperature at 0 Kelvin, it has some resistance or resistivity. Okay, some value of resistivity, this is one definite value at 0 Kelvin. After that one we are going to minus term, minus, that is negative temperature, its resistivity decreases and get 0 at one place, rho or resistance or resistivity. So resistance and resistivity nearly both are same. So at a particular temperature the resistance of the material becomes a 0, that means it is a become a superconductor. So in that phenomena is known as superconductivity. That material is known as superconductor. For mercury, that is Hg. For mercury 4.2 Kelvin, 4.2 Kelvin is the, that is this temperature is known as, when it reach the R is equal to 0 means that temperature is known as critical temperature or transition temperature. That transition temperature 4.2 for mercury. Okay, at 4.2 Kelvin mercury become a superconductor. So this temperature is known as transition temperature, because ordinary conductor becomes a superconductor in a particular temperature, that temperature is known as transition temperature or critical temperature. Okay, yes. Then this phenomena is discovered by Hammerling Owens in 1911. So 1911, Hammerling Owens, that scientist, discovered that phenomena for mercury. Okay, so this is very simple term. So study that one. Okay, yes. In this topic, lot of 1 marks is will coming in exam. Okay, thank you.